Greetings, curious minds. Google I/O 2026 wasn't just about new models. It was about a complete rebuild of the developer stack for the Agentic era. 3 massive developer tools dropped within 24 hours, and most content is still focused on Gemini 3.5, Flash. But that's not the real story. The real story is what Google just gave developers who want to build, debug, and scale AI agents. Let me walk you through it. Let's start with the headline announcement, Antigravity 2.0. Antigravity was originally a VS Code fork. Version 2.0 is something completely different. Google removed the code editor entirely and rebuilt it as a multi-agent orchestration platform. The flagship product is now a standalone desktop application that orchestrates up to 4 to 5 agents working in parallel. And in the keynote demo, they ran 93 agents simultaneously building the core framework of a working operating system. 12 hours, under $1,000 in API costs. And when Doom failed to load because it was missing keyboard drivers, Antigravity generated the drivers in real time. Now here's what most people are missing. Antigravity isn't just one product. It's a shared harness, the same reasoning loop, sandbox management, and safety policies that power Gemini Spark, the consumer agent. One engine, multiple surfaces. The desktop app includes a built-in Chromium browser for visual verification. Agents take screenshots and record videos to verify UI correctness. Voice commands using Gemini audio models with live transcription. And scheduled automation. Set it and forget it. But the real news for developers is the CLI. The Antigravity CLI is Go-based, replacing the Node.js Gemini CLI. It features asynchronous workflows, kernel-level sandbox isolation via Apple's seatbelt on macOS, credential masking so agents can't read your .env files, hardened Git policies, domain allow lists, and terminal approval prompts before any command executes. It's essentially a hardened, production-ready agent execution environment. And now there's the Managed Agents API. Single API call spins up a full autonomous agent in a persistent Google-hosted Linux sandbox. Pricing runs 30 cents to $5 per interaction, depending on complexity. For context, that's roughly 1/5 the cost of running a comparable Claude Code workflow through the API. Now, the second major announcement that changes everything for developers building multi-agent systems, the A2A protocol, agent to agent, is Google's proposal for how agents built on different frameworks by different vendors on separate servers can collaborate as peers, not as tools, as agents. Think about what this means. Right now, if you build an agent with LangGraph and wanted to hand off a task to an agent built with Google's ADK, you need custom glue code, custom authentication, custom everything. A2A standardizes that. The architecture has 3 layers. L1 defines canonical data structures. Tasks, messages, agent cards, parts, artifacts. L2 defines operations, send message, get task, subscribe to task. L3 defines transport, JSON RPC, over HTTP, gRPC, REST. Agent cards are particularly clever. Each agent publishes a JSON document describing its capabilities, endpoints, and authentication requirements. Your agent queries the registry, finds the right agent for the job, and hands off work without knowing anything about the other agent's internal state. This is Agentic Service Discovery. The protocol is designed to complement MCP. MCP gives an LLM tools to interact with external systems. A2A lets agents collaborate with each other. They stack. An A2A agent may internally use MCP to access its own tools. Supporting frameworks already include Google ADK, LangGraph, and BeeAI. SDKs are available in Python, Go, JavaScript, Java, and .NET. Google contributed it to the Linux Foundation, which means it's genuinely open, the comparison that everyone wants. A2A versus MCP. MCP is USB. It connects devices to computers. A2A is a social network. It connects agents to each other as peers. Different abstraction layers. Different problems solved. Here's the one that web developers in particular need to understand. WebMCP. WebMCP is a proposed web standard from a joint Microsoft and Google team that lets any web page expose JavaScript-based tools directly to AI agents. Your website, running in Chrome, can be an MCP server. No backend required. The core API lives in window.navigator.model context. You call register tool with a name, description, input schema, and an execute callback written in JavaScript. The browser's agent observes the page's tool map along with screenshots and accessibility data. Tool calls invoke your JavaScript on the main thread. The real-world example that shows this isn't theoretical. It's already in production. In Garrett, the code review tool for Chromium, developers are using WebMCP to let AI agents file suggested edits. Check CI try-run statuses and get failure snippets, all through browser-based tools that the user's agent can see and invoke. The origin trial is expected in Chrome 149. It's a W3C community group draft report. Early days, but the trajectory is clear. Why does this matter for you? Because the web is the universal interface. If your application can be a tool that agents discover and use, your product becomes part of the agentic workflow automatically, without an API key, without a server, without infrastructure. WebMCP and A2A are actually complementary. WebMCP is how agents interact with web pages. A2A is how agents interact with each other. Together, they form a complete picture of agentic interoperability. Rounding out the developer stack, 3 additional tools that deserve your attention. Android Bench is Google's LLM leaderboard specifically for Android development tasks. It evaluates models on real Android code bases. Kotlin Gradle Jetpack Compose, with actual test verification. The current leader is Gemini 3.1 Pro Preview at 70.8% pass rate on the first try. Claude Opus 4.6 sits at 66.4%. These numbers are close enough that the real story is generational. Every current flagship model significantly outperforms models from a year ago. The benchmark also tests 20 tasks with screenshots. Multimodal Android development. Gemma 4 and other open-weight models are now included. AI Studio got a major mobile update. The mobile app lets you build native Android apps via natural language prompts, vibe coding in Google's terminology. Kotlin code generated using Jetpack Compose. No SDKs to install, no software to manage. Export directly to Antigravity with your full conversation history, project files, and secrets. And one-click publishing to Google Play's internal test track. DevTools for Agents was a brief mention at I/O, forward-looking announcement for real-time debugging and optimization of AI agents, similar to what Langsmith, AgentOps, and Helicone offer in the broader ecosystem. More details expected as Antigravity 2.0 documentation matures. So what's the takeaway? Google isn't just building models. They're building the infrastructure layer for agentic AI. Antigravity gives you the execution environment. A2A gives you agent interoperability. WebMCP gives you web integration. Android Bench gives you benchmarks. AI Studio gives you the fastest path from prompt to published Android app. If you're a developer building agentic systems today, this stack is worth serious evaluation. The Managed Agents API at 30 cents per interaction undercuts most competitors. The A2A protocol solves a real problem that every multi-agent developer eventually hits. And WebMCP, once it ships, could fundamentally change how web applications participate in the agentic economy. The agentic era isn't coming. It's here. And Google just handed you the keys. I'll see you in the next one, Curious Minds. Until next time, Curious Minds!